So we have f prime of x, which is the first derivative. Then you can write f double prime, which would be the second derivative, which means you just take the derivative of the derivative. And then you just keep going down the line here. F triple prime would be the third. Once you go past the triple prime, they would just write the number. So F4 is the fourth, and you can just keep going to infinity, basically. You will also see this notation. So we have dy dx for the first. For the second, they would write d squared y over dx squared. So if you ever see something like that, this is just asking for the second derivative. That's all it's saying. All right, let's look at if you have f of x is equal to sine of x. What's f prime? What's the derivative of sine? Cosine. And then I want f double prime. So now I'm doing the derivative of the cosine function, which is negative the sine. And then if I want to do the third derivative, that's the derivative of negative sine, which is negative cos x. And then if I asked for the fourth derivative, you would tell me it is sine of x. Sine and cosine recycle after every 4. Get back to the original. Okay? If you have a polynomial, so if I have some sort of polynomial, 3x cubed, 2x squared plus 1. And I said, okay, what's f prime? What's f prime of that? Plus 4x, because the constant 1 will go to 0. And then if I ask for f double prime, you get 18x plus 4. And if I asked for third derivative, would be 18. And if I asked for the fourth, you would tell me it's what's the derivative of 18? 0. And then everything after that would be 0. So polynomials will always go to 0 if you just keep taking the derivative enough times. Okay. Sorry? Yeah, it's just how many times you have to do it, right? So if it's a degree 3, we had to do it 4 times to get to 0. So if it was a degree 5, you'd have to do it. If it was a degree 58, you'd have to do it 59 times, right? If it was x to the 58, you'd do it 50. It's always one more than what the degree is. Okay? So what if I said this? F of x is equal to, let's make this x to the 7 plus 2x squared minus cos plus cos of x. And I said, I wanted to know what is f of 8 equal. So the polynomial part is all going to go to 0, right? So that's going to go to 0. What do the trig functions do? After every fourth, it repeats, right? So if you actually went through and did it, after the fourth derivative, you're going to come back to cosine. After 4 more, you're going to get cosine again. So the answer would just be cos of x, or 0 plus cos of x. Okay, so if I give you a question like that on a test, I mean, you can just go through and do all 8 derivatives if you really want to. But if you want to save yourself some time, you know this goes to 0, and then the cosine just repeats, or the sine just repeats every 4 derivatives. Okay. All right. What if I asked you this? I go f of x is equal to, let's just make this 2 over x plus 1. Nice and straightforward. And I said, I want to know what f double prime is. This is not a polynomial function. Okay, remember, polynomials don't have variables in the denominator. It's a rational function, so it's not going to go to 0. So we actually have to do it. Okay, so we do f prime. Do you want to use product or quotient? What do you want to do here? Product, so you want to rewrite it as 2 times x plus 1 to the negative 1. And then you're not even really using product, you're just using chain rule, basically. All right, but that is the easier way to do it. So what's, excuse me, what's f prime? Drop the negative 1 down. X plus 1 to the negative 2 times the inside, which would be 1, so nothing. So there's your first derivative. So my second derivative is the derivative of that, which is going to be is that going to be positive 4? To the minus 3, right? Which is just 4 over x plus 1 to the 3. Okay? Is that okay? All right, let me finish this last thing, and then it'll be break, and then I'll give you some time on the other side to do a couple questions, then we'll do the last thing today. All right. Is there a faster way to what, sorry? Yeah, like to find the derivative? Yeah, when we have more degrees of if it's a polynomial, you can just look at it and go, something's going to go to 0. If it's like this, no, you just have to grind it. So I won't ask you to do like a 7th degree derivative, okay? All right, so if we have, who's done physics 11? Most people, okay. If you remember in physics 11, I think I've talked about this before, you would do time position graphs for the little ticker tape thing. Position would be in meters, time would be in seconds. You get some sort of curve, and then you drew a tangent line. We talked about this. And you would do the rise over the run of that tangent line. Which was, if we were just looking at the units right now. So the rise, the position is in meters. The run is in seconds. What has units of meters per second? Sorry? Speed or velocity. And that is the slope of that line. which means it is the derivative, which means f prime of x, when you're talking about position time graphs, is equal to the velocity function. Okay, so the first derivative, if it's a position time graph, gives you the velocity function. If I take the derivative of that again, I'll end up with s squared, second squared on the bottom, because it's how fast the velocity is changing with respect to time, otherwise known as acceleration. So the second derivative is the acceleration function. Now, you can keep going with derivatives, just like we learned. Those are the two that are used most often, but if you go on in physics and become an engineer, things like that, the third derivative is called the, does anybody know? It's called the jerk. And that is how fast the acceleration is changing. The fourth derivative, not that we're ever going to use this, and it shouldn't be a Roman numeral, it should be a 4. Anybody know? Is the snap, or the jounce, it's sometimes called. And then because they called that one the snap, what do you think they call the next two? The crackle and the pop. And the sixth derivative is this. Now, a friend of mine is an engineer. He actually uses, the jerk is actually important, how fast you accelerate, because he works on machines that do very fine cutting. So if you accelerate too fast, the machine moves and you lose your precision when you're cutting, like they're going to the angstrom or the nanometer in terms of precision. And then he told me that, I can't remember if it was snap or crackle, is actually used by drones. It's important in drone flying, but I can't confirm that. I'm not an engineer. So these names, I mean, they don't really have names. They just kind of made up stupid names because they're engineers, and that's what engineers do. So, but the only ones that we will really focus on are the first two, velocity and acceleration. Okay. Some questions, and then you can go on break, page 127, 91 to 97, odd, and 115, please. And you can go on break. You're used to seeing things written like y is equal to x squared plus 2, or y is equal to 3x plus 1, or y is equal to sine x, or whatever. That is called explicit form. Because you're writing the function explicitly in terms of y. Y equals, or in terms of x, y equals x squared plus blah, whatever. All right? If I take the same equation and I wrote it this way, y minus x squared minus 2 is equal to 0. All I did was move everything to the other side. This is called implicit form. Okay? Now, if you can write it as y equals, write it as y equals. All right? All functions can be written that way. However, not everything is a function. And some relations cannot be written in terms of y. So, for example, if we have x squared minus 2y cubed plus 4y plus x is equal to 2, that's some sort of weird relation. And we can't write it as x equals or y equals. Can't solve for x or y here. Okay, you're gonna have square roots and everything. So this is implicit form. So we have to use what is called implicit differentiation. Must use. All the same rules apply that we have learned, okay? There's a key point here, though, thing to remember. When using let's say we are be careful of which variable you are deriving with respect to. So for example, I say dy dx, x variable. All right, we're deriving with respect to x. If I wrote dy dt, time is our variable. Okay, so whatever the denominator is in the dy dx or the dy dt or dy d theta, it could be anything. And when you have that, you derive normally. If you don't have that, well, you know what? Let's just do it. It's easier if we just do it. So let's do, okay. I'm asking for the derivative of x plus 3y. So what variable am I deriving with respect to? X, right? Whatever's in the denominator here. So when it matches, when this variable matches the variable that you're deriving, it's just regular derivative rules. So if I just said, what's the derivative of x with respect to x? You would say 1. Okay. So because those match, it's normal rules, and I get 1 for that part. Plus, now, constant 3, what can I do with that? You can kind of pull it out, right? Same rules apply, so I can just pull out the 3. Now, I'm deriving y with respect to x. And when they don't match, when this and this don't match, you use chain rule. Okay? In this case, we're just going to say, what's the derivative of y with respect to x? It is y prime. We don't know what y is. We can't solve for it. Okay? So we just go, that's y prime. Now the other way to write it is, instead of writing y primed, you can just write dy dx. And that's technically what you should do. And when we do rate problems, it makes way more sense to use that notation. But if you write y primed, that's fine, because you'll see that these questions can get quite big. All right, so if you have dy dx's all over the place, it can get a little nasty. So, and that's it, you're done. That's the answer. We don't actually have an equation right now, so we're just practicing these. So if I said the derivative with respect to x of y squared, do the variables match? No, so we have to use chain rule. Chain rule says, what happens to the 2? 2 falls down. Put a 1 there. You don't have to put a 1. I'm just doing it to illustrate the point. And then you multiply by the inside derivative. What's the derivative of y with respect to x? Y prime. So I should erase that 1 because it looks like a prime. So it's 2y times y primed. And that's it. You're done. Or if you wanted 2y times dy dx. Y primed and dy dx are the same thing. All right. Does everybody feel okay with that? If the variables don't match, use chain rule if there's an exponent, or product rule, or you'll see. And you always have to multiply by y prime. All right, let's try a actual equation here. What is dy dx for this thing? Y cubed plus y squared minus 5y minus x squared is equal to 4. Okay, so we do the derivative of the whole thing, both sides of the equation. So what is the derivative of y cubed with respect to x if they don't match the variables? What do I do first? Sorry, what did you say? You're close. So you drop the 3 down, but you take 1 away from that exponent, right? So it's 3y squared times the derivative of y, the inside derivative, which is y primed. This is why you don't write ones, okay? Because that's not a 1, that's a y primed. So just be careful of that, unless you're actually writing your ones with the little hat and bottom thing. Plus, now I do the derivative of y squared. What's the derivative of y squared? 2y y primed minus the 5 can just stay there. What's the derivative of y with respect to x? Sorry? Of y, like this y right here. What's that derivative? Y prime. Minus, what's the derivative of x squared with respect to x? 2x. The same rules apply, right? Because those variables match, so you just do the derivative as normal. So it's minus 2x. Equals, what's the derivative of any constant? 0. Okay. Now we got to solve for y primed. So anything that doesn't have a y primed goes to the other side of the equation, which is only the 2x. I need to solve for y primed. What am I going to do that? I need to get y primed by itself. Factor out of y primed. And then divide off everything in brackets. And that's your answer. You could write dy dx. That's it. It's going to be the same process every time. You're going to take the derivative. You're going to get this big ugly thing. You're going to put all your y primes or your dy dx's to one side. You're going to factor out a dy dx or a y prime and divide off. Okay? So we'll try another one here. dx. Okay. So I have to take the derivative of the whole thing. So let's start with this bit here. That's two functions being multiplied together, which means you have to use what rule? Product rule. So product rule says the derivative of the first function, so the derivative of x squared with respect to x is what? 2x. Times the other function, which is y, plus the derivative of this function, y, which is y prime, times the other function, which is x squared. That is the derivative of x squared y, implicitly. Then we move on to this next expression here. So it's minus. Whenever you subtract something, please put it in brackets, because this is where people always make a mistake. So you put that in brackets. Now, two functions being multiplied again. So we use product rule again. Derivative of the first function, y squared. What is the derivative of y squared with respect to x? 2y times y prime. Times the other function, which is x, plus the derivative of x, which is what, sorry? That's 1, right? Times the other function, which is y squared. Equals what? 0, because it's a constant. Okay, calculus is over. Now we have to isolate the y primes. So this negative will get dumped in there, and you can see it's going to flip the signs. So I'm going to get and that should be a minus on the y squared. There we go. Okay. Anything that doesn't have a y primed or dy dx, depending on how you write it, has to go to the other side. What's up? Where did I forget the x? Oh, right there. From that one, right? X minus y squared is equal to 0. There we go. Okay. Anything that doesn't have a y primed goes to the other side. So then I have y primed x squared equals y squared minus 2xy. Now what? Factor out y primed. Divide it off. And that is your derivative. Okay, there's really only one trick. I shouldn't say only one trick. The real trick is when you're subtracting and things are being multiplied together, bracket it because it flips the sign. Okay? All right, is everybody okay with that? Once you do it a couple times, it'll start to make sense because it's the same thing over and over again. Let's hang on to do those ones. Let's do page 145, numbers 1, 5, and 9, please. And I got one. Okay. So find dy dx for sine x plus cos y is equal to 1. So dy dx for sine of x. The variables match. So we just do the derivative as normal. What's the derivative of sine x? Cos of x. So I get cos of x plus cosine of y. So the variables do not match, so we have to use chain rule. What's the derivative of cosine? Negative sine of y times, what's the derivative of y with respect to x? Y prime equals 0 because it's a constant. Now you have to solve for y prime. So I'll move the cosine over. So I get negative sine of y times y prime is equal to negative cos of x. And then I divide off the negative sine y. And the negatives will cancel, and I get cos of x divided by sine of y. That is not tan or cotan because the variables are different. So you just leave it like that. And that's it. So even with trig, you just have to be careful. If the variables don't match, use chain rule. Okay? Now, the other type of question I will ask you is if I give you an equation where you have to use implicit, I could ask for the equation of the tangent line or the slope at a certain point. First step is to do the derivative. So what is the slope of this? So we have to find dy dx. So dy dx equals variables match here on the x plus 2 all squared. So I just do it as I normally would. So I go chain rule, drop the 2 down. X plus 2 times the inside derivative, which would just be 1 in this case. Not that you have to write the 1. Does everybody understand that part? Plus, so I'm doing dy dx for y minus 3 over to the power of 2. So I have to use chain rule again. 2 falls down. What? Y minus 3 power of 1 times the inside derivative, which is y primed, equals equals 0. Okay. Now, at this point, if I'm asking for the specific slope, you don't need to solve for y primed right now. You can just plug in your point. Okay? So if we just plug in the point 4 and 4 for x and y, I get 2 times 4 plus 2 plus 2, 4 minus 3 times y prime is equal to 0. 4 plus 2 is 6 times 2 is 12. 4 minus 3 is 1 plus 2 is 2, so 2y prime equals 0. And then you can solve for y prime because it's a lot easier. We've cleaned things up. So 2y prime is equal to negative 12. So y prime is equal to negative 6, which is your slope. All right. That okay? All right. So it's the same thing, except now I give you a point. You just plug it in, and it spits out the slope. 2 questions, number 11 and 31. And that is it for this unit/day. On same page.